Good morning. So in this particular section we are going to discuss regarding cables. In previous class we discussed regarding arches. See, these two things, arches and cables, both are we generally using in long span structures. So in here we are discussing regarding cables. This is suspension type of cable. So here we are having different things like suspension cable, anchor cable. It's just for a long span of obstacle like any roads, there's a river, it's an obstacle. So we are going to construct the bridge. So here we are having roadway. This is the thing, the structure is supported by the cables, different types of cables. So generally in this particular analysis, we are going to study some analysis things required like tension, stress, and also the length of the cable. What is the required length of the cable for some certain loads? Especially generally we will provide depending on different classification, IRC classification. We know some loads, what are the different types of loads acting on the structure. It may be point load or it may be uniformly distributed load. So we know different types of loads. Then we have to compute some analyze thing like tension and length of the cable and all. So here generally this is the general figure of suspension bridge, suspension cable. Here this anchor cable. For this particular thing, this is the analyzing diagram. See, generally arches are just like it's a reversal. So here in arch we are having rise, here we are having dip. So the same thing, it's a crown. In arch is a crown, it's a dip point. In rise point we are having crown in arch. Here the same thing, in dip point we are having point C. And generally A and B are the two supports. Here also it's a symmetry cable in the level, symmetry in level. Therefore A and B both are at same level. And also it's a uniformly distributed load because of some slab load, or it may be uniformly distributed. So VA, VB are the reactions. So in this also we are having generally the first step is determination of external support reaction. In this analysis also we are generally adopting the first step is determination of external support reaction, that is VA, H, VB and H. So generally these are the type of structure holding tensile forces. Tensile force plays a crucial role in case of analysis of cables. Hence the tension of the cable is given by square root of V square plus H square, where V is the maximum vertical reaction. We are having, there are two reactions, VA and VB, out of which is maximum V value. That is the thing we have going to consider in this equation. H is same. H, both HA and HB equals H, therefore H is same. And T minimum value. What is the minimum tension produced? The T minimum value is H. T minimum value is H. It is at the lowest point. Lowest point because if different level we are getting different values of H's. So the next, once we determine tension developed in cable, the next part is size of the cable. To determine the size of the cable, required size of the cable for particular type of load or particular value of load, we know the basic things from mechanics of materials. The stresses developed in any material is equal to force per unit area, force by area, sigma equal F by A. Here sigma generally we will given in a problem. So we have to utilize that particular sigma value, and this is the force. Force means what is the maximum tension developed in the cable. So T max divided by area. Generally we will assume a circular cable. So the area is given by pi d dash square by 4. This is the area of cable, where d dash is the diameter of the cable. So we know sigma, we know T max, we can easily compute what is the required diameter for the particular given problem. So diameter, in this particular we are going to study the how to compute size. Size matlab that is diameter of the cable. In next, once I know what is the size, required size, next what is the required length. There are two types of problems generally we are having in this particular section. That is supports at same level, supports at different level. If we are dealing with supports at same level, we have to use this formula S equal L plus A by 3 d square by L. You are not having the derivation part, just refer this equation to solve the problem. If in the second case, the supports at different levels, say for example, here you are having A support, here you are having B support, with respect to C deep, you are having D1, where D1 is the depth with respect to chrome from support A, where G2 is the depth from support B to chrome. We are having generally when C it's not at symmetrical level, correctly L we are having different length for chrome. But if it is same level, exactly in this case, the C is at L by 2, L by 2. But in this case, C is not exactly at half of this span. It differs. Therefore, we are having L1, we are having L2. So, generally, then the length of the cable is computed using this equation L plus 2/3 of D1 square by L1 plus D2 square by L2. Where L1 and L2 are these lengths of the cable with respect to support A, support B with respect to C point. And where D1, D2 are not diameters, don't confuse. D1 and D2 are the depths. D1 and D2 are the depths with respect to supports A and support B. Clear? And L means this is the given length. L is this. Don't confuse with this is the length of the cable. This is the span length. This is the span length. Where S is the length, total length required for the cable analysis. So I hope in this particular lecture we deal with some basic aspects related to analysis. In next lecturing section we are going to discuss regarding some forces developed in cable when we are providing different types of supports like saddle or anchors. Okay, so this is the thing you have to remember. In next class we will deal with some few problems. Thank you.